Our final panel of the day will be the future of spectral. And the moderator for this panel will be Dr. Jamie Goodman. Jamie is the president and CEO of HySpeed Computing. Dr. Goodman has 25 plus years of experience in remote sensing, mathematical modeling, image spectrometry, high performance computing, and specializes in the development of advanced image analysis algorithms and tools. And with that, I will go ahead and turn it over to you, Dr. Goodman.
Thanks, Joey. Everybody hear me okay? Excellent. Thank you again, and welcome everyone to the last session of the day, the future of spectral. I'm going to start off. We're just going to jump in and let's introduce our panelists for this afternoon's or this morning's or evening's, depending on where you are in the world, this session. First, we have Dr. Tom George. Tom is the CEO and founder or co-founder of SaraniaSat. This is a company focused on high spatial and high temporal resolution hyperspectral imagery. In that role, he's currently a co-investigator on a hyperspectral thermal imager. It's a space mission recently funded by NASA. His company's also recently been awarded 2 SBIR Phase 1 contracts from the US Air Force for some aircraft-based remote sensing. He also has experience as a senior executive in multiple small companies, and notably has also spent 15 years at JPL, where he managed the Micro Electromechanical Systems Technology Group. Welcome, Tom.
Thank you.
Next, we have Dr. Fabio Pacifici. Fabio is a fellow scientist and distinguished member of the technical staff at Maxar. His focus is really bringing together the satellite industry with computer vision and deep learning communities. So he really wants to join all kind of like the new hot topics and the old hot topics and bring them all together. His expertise and really his passion, crosses a whole bunch of different remote sensing domains, from signal processing, data fusion, hyperspectral, SAR, change detection, and so many others. He's co-authored more than 100 publications and received numerous international awards for his research as well. Nice work, Fabio, and welcome.
Thanks.
And then we have Dan Katz. Dan is the CEO and co-founder of Orbital Sidekick. This is another company fast-paced on getting a space-based hyperspectral infrastructure to provide monitoring and solutions for the energy sector and a whole bunch of other verticals. Prior to that, Dan spent 5 years at SSL, which is now part of Maxar. And he previously worked on civil infrastructure programs and has a background in physics and aerospace engineering. Welcome, Dan.
Thanks, Jamie.
And then we have Amanda O'Connor. Amanda is an industry principal. I think she was introduced earlier for anybody who saw the opening keynote, but she's an industry principal in remote sensing at L3 Harris Geospatial. She's been with the company for 15 years now, supporting a whole host of different government, commercial, and educational customers, pretty much working on solving hard remote sensing problems. She's a great go-to person for all things remote sensing. Notably here, she has 20 plus years of experience in spectral analysis. And in 2019, spent a year with Teledyne Brown Engineering as the Director of Geospatial Solutions for the DESIS Hyperspectral mission on the International Space Station. Welcome, Amanda.
Thank you, Jamie.
And I guess before we get started, I'll throw in my 2 cents before I turn it over to all of you. I've been working, in hyperspectral data for over 20 years now, and my perspective on the future of hyperspectral is that it looks very promising. One of the key concepts that defines this technology is I've been referring to it as spectral agility. So it's the spectral detail, it's the spectral resolution of this technology that gives us agility in the diversity and the accuracy of both algorithms and applications that we can implement. So it's not just the depth of a particular application, it's the breadth of applications that spectral analysis brings to bear. And I think it's been a little oversold in the past. So, you know, it is definitely fair to say, you know, it's not the answer to all our remote sensing needs. We've got to be aware of what its where its strengths are, weaknesses are, and apply it where it's most appropriate. Also contributing to the future from an instrument perspective, these same barriers we've seen falling elsewhere in the remote sensing industry, you know, multispectral sensors and SAR sensors, you know, driven by instrument miniaturization, cost efficiencies, reduce launch costs, you know, improve data processing efficiency, all those things. This is also falling in the spectral domain, you know, and we're seeing this. The government is now launching multiple sensors. I mean, you have DCIS and Hisui, both hyperspectral sensors on the International Space Station. There's the Prisma sensor, which is a free-flying sensor currently up. NASA has their SBG mission up and coming in about 2027 or so, as does ESA with the Copernicus Chime sensor, also in the same time frame. And then we've got these commercial ventures that are coming in right at the same time, as represented here by SaraniaSat and Orbital Sidekick, and there are others. So people are getting into the hyperspectral game, and it seems that it's really finally coming of age. You know, the thing is though, I've heard this before. We've all heard this before. You know, for 20 years now, we've heard hyperspectral is coming. So it's shown great promise, but broad scale adoption has been pretty slow. So some have said it's due to the large data volumes, others that it's difficult to work with. You know, I think, have we overcome these hurdles? Are we there yet? And I think the answer is yes. But what I'm really looking forward to hearing is what the panelists have to say on this. I think we'll have a pretty lively discussion. So enough of me. Let's see what you all have to say. As I just mentioned, we're seeing a lot of growth in both industry and the government academic research side in hyperspectral remote sensing and spectral analysis in general. Tom, if I could ask you, is this trend here to stay? And what roles do both government and industry play in continuing it?
Yeah, thank you, Jamie. If you'll indulge me, I had a few slides, so rather than the audience looking at my face, I'd like to share them, if that's okay, with your permission. So I'll start with talking about complexity. So leading off on what you had mentioned, the point that I'd like to raise is that today's world is it's getting more and more complex. And our keynote speaker today, Dr. Prasad Thenkabale, and other speakers made an excellent case for complexity that can be addressed by hyperspectral data. And as you know, we have many complex and interconnected effects that are occurring in Earth-based phenomena that require big data, such as hyperspectral data, to match the complexity that is for answering these questions. Unfortunately, and I'm possibly being controversial here, as you kind of alluded to, the trend in remote sensing thus far has been to simplify, and sometimes maybe simplify to the point of meaninglessness. And so here we have to take guidance from Einstein when he said that everything should be made as simple as possible, but not simpler. So if we need clear evidence of complexity as a driver, we need to look no farther than the internet or our mobile phones that are far more recent inventions than remote sensing, but individually have markets that dwarf the small remote sensing data market. And this is precisely because both of these modalities drill down on a lot of complexity to deliver the precise information that decision makers need at the time that he or she needs it. And unfortunately, remote sensing is nowhere near this level of complexity and timely delivery of actionable information. And one clear example, I believe, is the prestigious LandSat program that has been the flagship Earth observation program for several decades. And despite its many impressive accomplishments, it's not yet a household word because it does not have the spatial, temporal, and spectral resolution to answer many complex questions. And add to it the latency to get actionable information. And you mentioned this, that there's that aspect of too much data. The latency is too high for daily decision making. So just as in agriculture alone, as Dr. Prasad Thinkabale had spoken very eloquently about the problem in his keynote speech, complex hyperspectral signatures with high spatial and temporal resolution are needed in order to get accurate and crop-specific prescriptions with low false positives and false negatives. So I believe we need a strong partnership between industry, government, and academia in order for industry to develop and drive the business case, governments to make this a national priority and also drive the policy development, and academia to drive the innovation necessary for the acquisition of what I call H-cube data, hyperspatial, hypertemporal, and hyperspectral signatures of various phenomena combined with rapid data analytics to deliver the actionable information in the hands of the decision makers as quickly as possible.
Thank you, Tom. Yes, good points. And in fact, from some of my own work and colleagues, there's been a similar push within the coastal remote sensing community to pursue this hyperspatial, hypertemporal, hyperspectral approach. So I appreciate that. So kind of with that in mind, Dan, let me jump to you. So, you know, your company's heavily invested in hyperspectral. However, you know, is this just another tool in the toolbox? You know, there's a lot out there. Where do you see this fitting in?
Well, I think it's an important tool in the toolbox, but it is one of many. I always, when I look not just at hyperspectral, I also look at the platforms as well. And we focus on space-based hyperspectral. And even the platform of satellites is also just another tool in the toolbox. It's all part of a larger system of systems where we look at a layered approach with anything. If we're monitoring, I mean, the key here is providing a monitoring solution and a monitoring service to the end user. So not being too in love with any single technology or any single platform or delivery mechanism. So, for example, when we look at our energy customers that we specifically are focusing on oil and gas pipelines, we're not as concerned with the exact type of data we're collecting or even the exact platform we're collecting from, but we know that we need to deliver actionable information to our end users that's accurate and objective. So it really is, and we've talked about this before the panel, I think almost a de-emphasis on hyperspectral as the magic bullet here. I mean, there are lots of different tools we can utilize. And I think what's also really important is recognizing that, yeah, I mean, hyperspectral is, it is very powerful. And as we continue to get onboard processing capabilities on platforms, we'll be able to sort through large data sets and extract real-time actionable information from these data sets. Hyperspectral is going to, you know, the power of that is going to grow exponentially. So yeah, on one hand, you know, we are based and we've built our architecture and infrastructure around hyperspectral, but when we are customer facing, we almost de-emphasize that there's one specific tool we use because we can lean on, I mean, we've ingested multimodal data from, you know, panchromatic, multispectral, SAR, even looking at IoT, looking at different types of sensors on, you know, fiber optic sensors tied in with pipelines and other methods as well for detecting threats or leaks or other types of actionable information. So it really is, you know, it's one arrow in the quiver, one tool in the toolbox. It's very powerful though, and I think it will continue to gain more power, more leverage as our compute capability increases.
Great, thanks. Yeah, all good points. So continuing on that, Fabio, we've had a discussion on this before, is, you know, I mean, Dan's mentioned this is a powerful tool. It's one tool in the toolbox, but it is very powerful, but it's still seeing this slow adoption. What can we really do? Or maybe what have been some of the hurdles that we've needed to overcome, and what can we do as a community to help champion hyperspectral?
Well, so I think the remote sensing community right now, it's in a very exciting time for many reasons. One of these is that the new platforms that are coming online, they actually provide like some sort of like orthogonal piece of information to Hyperspectral in general. For example, look at the temporal component with intraday revisit. The spatial resolution are getting better and better with each new launch. And look at the new modality are coming up online. Just a couple of days ago, SpaceX launched multiple SAR payloads from different companies. So I think all these will allow will allow better data fusion and sensor integration. And so I kind of agree with them that Hyperspectral is just one of those components, and we should try not to focus only on one component, but try to understand how we can exploit each of these domains for that very specific application. And in general, I think we talked about this the other day. In general, I think we leave a sort of intersection between different domains. The intersection between AI, artificial intelligence, computer vision, and remote sensing. And so those are also other tool sets that we have in our arsenal to address a very specific application. And if you're just now getting to the remote sensing domain, you should probably be familiar with them, because I think they're not going anywhere. Just in the past, like 3 to 5 years, there's been an explosion of AI application. For example, classic machine learning applications such as like object detection, change detection, segmentation, like use lane cover. Those are just a few that have been done in story for probably 20, 30 years. But now with the advent of like deep learning, there are new applications such as, for example, punch sharpening, like a deep learning punch sharpening method, or 3D extraction, or I've seen a really fantastic thing in domain transfer using, for example, cyclogen, where users were able to translate a SAR image into an optical image, or for example, translating an image from a winter scene to a summer scene. In general, with GANs, you can generate completely fake images that look very realistic. And you can use those images, for example, for gut feeling or for train new models. And I've seen in the chat, someone was asking, yeah, we don't have many hyperspectral data sets that are available. This is really true for the whole remote sensing community. There are not that many data sets like ImageNet or COCO that are out there. But for example, we can use GANs to generate them. How applicable that is, it's something that we're still investigating, but that's one possibility. But definitely the lack of training sets is what it's slowing down adoption in the remote sensing community with respect to computer vision. I just have one other thought that I would like to bring it up, which is something that Prasad mentioned this morning during his keynote speak, which is ARD, analysis ready data. Generally, ARD is understood as a co-aligned stack of multi-temporal, multi-source images that are somehow like radiometrically consistent, and they're interoperable across different sensors. Unfortunately, there is not a good consensus across the community about what ARD really means. And for example, there is a CEOS standard, there is a OGC standard, and IEEE standards, but there's really no clear acceptance about what ARD means and what is the ready for, what kind of application. And in general, you can range from like minimal calibration for car counting, for example, to very accurate surface reflectance. But still, you need to deal with BRDF when you have multiple multi-view collections. And so ARD is something we really need to, I think we need to focus as a community to try to make images more easy to use to the end user. So I don't know if I answered your question, but there are a lot of like random thoughts that I have.
No, that's all great.
I was trying to keep an eye also on the chats here.
Yeah, no, you hit on some of the stuff in the chat, some of the questions from the audience. And and it's commonalities. You're pointing out commonalities that are true throughout the entire remote sensing community. And it's essentially bringing spectral analysis, we'll say, up to speed with some of the other practices elsewhere.
Yep.
And then dovetailing into a question for Amanda, this is the tools, making hyperspectral more accessible to not necessarily the end user, but the analyst, the real data user community, and making this more digestible. You know, where are we at with that? Where do you see that going?
Thanks, Jamie, and gosh, lots of good info from Fabio and Dan and Tom. Wow. So as far as like, you know, making complex data available to the end user to work with, I think Fabio was hitting on it with analysis ready data. And, you know, there's certainly limitations with analysis ready data. On a recent project I was working on, we had ARD data from Maxar, we had it from Airbus, we had some pre-processing done by me, and it was all like, you know, atmospherically correct. We're trying to get to surface reflectance, and they all look different. And so getting to a standard of what analysis ready data pre-processing looks like, to me, is a key feature of getting that data to an analyst who can do something with it. Whether that's multispectral or hyperspectral data, is just having that pre-processing from doing your radiance correction, your atmospheric correction, and doing any kind of co-registration ortho so that you can compare it to other images within a stack or mosaic it, to me, are the key pieces that are some of the harder ones that you can trip up on if you're not quite sure what you're doing. And I think that's really key for the community to try to get to a better place, especially if you're mixing and matching sensors, which remote sensing are opportunists. They're going to use whatever they can. So I think, to me, that's key. That's step one. And then step two, to getting it to the analyst, it's like, I think of it as a fork. You have, that piece of getting the data ready. And then you have, like, the myriad of chutes and ladders you can go down to get to an answer. So for an analyst to get to an answer, it's just key to understand what their problem is. And once you understand the problem is, it's like, you back propagate it to get to the analysis that you need. So what, Fabio was talking about, like, automated intelligence and finding certain things and in an image. And yes, you can do it spatially. And that's where high resolution data, I think, really is important. And high resolution multispectral data is really, at this point in time, a key tool for that type of analysis, where you're trying to find, is a building damaged, or is this a high school because it's a building next to a track, as opposed to like hyperspectral deep learning or machine learning, kind of what Prasad was talking about this morning, where you're building training data sets based on the spectral qualities of certain materials, and then using that as a training source to go find it in other places. And those types of things can be automated. You have to make, robust tools, but that's one of the things that I think we do a reasonably good job at, or else I wouldn't be hanging around here for quite so long. So I think if you're able to enunciate what your end goal is, it's a matter of going back and finding that path, either with people who understand that, or an organization, or something else. But ultimately, we are working with data, and it can be complex, but I think we can get it to the tip of the spear of the people who need to apply it.
Great, thanks, Amanda. A few common threads I've been hearing from the panelists and seeing in the chat from our audience. We talk about limitations in data sets, particularly multi-temporal data sets. There are some out there, Avarice, as we all know, has, some multiple collects over the same sites. The NEON program in the US has multiple collections over the NEON sites. And then I know there's an effort to reprocess the Hyperion imagery. So, one of the earliest spaceborne hyperspectral instruments, and to reprocess that to analysis ready data using a common processing format chain. So with that said, though, so this starts kind of teasing out where are we going. So once we have Orbital Sidekick, SaraniaSat, you've got hyperspectral sensors doing multi-temporal analysis. What is that going to open up for us? You know, we're not just doing these one-off investigations anymore. Tom?
I think it opens up the space of phenomena that you could look at, just as, and again, I have to go back to what Prasad was talking about, and he was doing this excellent comparison between what multispectral was able to achieve and what hyperspectral was able to achieve. I mean, hyperspectral in agriculture, which was the specific use case that he was using, opened up a whole new panorama of different effects. Not only could you separate out individual crop types, but you could look at cultivars, you could look at the health of the crop across the entire growing season, how it responded to different effects. I mean, each crop responds differently to, say, the different inputs, the irrigation, fertilizer, crop protection, you know, and so on. So as you open up these parameters and you add these new axes of temporal and spatial, in addition to hyperspectral, and then both Dan and Fabio talked about other modalities being brought in, right? When you have true sensor fusion, I see that as kind of like a blind man and the elephant problem, right? Where each sensor is orthogonal to the knowledge that is being gained by the other sensors. But when you fuse them all together, then the true elephant comes out. And I'm guessing that there are a hell of a lot more elephants than we are tackling right now that can be addressed with the addition of these temporal and spatial information.
Dan, would you like to add to that?
Yeah, and I've struggled with this, what I'm going to say here, because I think it might be very unpopular. People might not like it, but the reality is for companies like Orbital Sidekick and other commercial companies, unfortunately, we're not really going to be able to open up the floodgates and allow our data to be accessed by other entities beyond the US government. And there are a couple of reasons for that. One, there's a regulatory issue with NOAA. And secondly, there is a data bandwidth issue. So I've talked about edge computing, compute power, onboard platforms, bringing down hyperspectral data cubes in their entirety, especially analysis ready data cubes that are rectified and calibrated. Bringing that down to ground is incredibly expensive. It's power intensive, and not just for a spacecraft, but for aircraft as well. So a big part of what we do on our platforms is we do data reduction and we extract information onboard the platform and get the data we need for our specific end user mission. So having a massive archive of hyperspectral data that is accessible to the broader industry is not really tenable, unfortunately. The good news, though, is that the cost of access to these systems and platforms, and whether it's handheld drone spacecraft, the access to that is being cheaper and cheaper, and I think more companies are going to be able to put their own sensors and other platforms in play. So I think that's good too. So, it's there's a third part to it as well that comes down to competitive advantage and proprietary access to information that I won't dive into too much. But like I said, maybe this is unpopular, but this is the reality we're living in, and so I did want to kind of make that aware to people, so yeah, that's kind of my stance there. So
Jamie, I have a quick counter to Dan, if I may.
Sure, you bet.
Because he wanted controversy, and so I'm going to give it to him. I think if you really look at the history of LandSat data, for instance, where the applications really exploded was when LandSat data was made freely available to anyone, anywhere in the world, right? And so, and I agree, that is not the purview of private companies to do that. It is what the government or an international policy should be doing, which is to increase the availability of these hyperspectral, hypertemporal, hyperspatial data sets in order for people to find new uses and do the exploratory types of investigations that typically academia is best at doing, right? Whereas businesses are focused on their bottom line and how they can maintain their competitive edge and so on. So it's a completely different, it shifts the game a little bit, but closing the door on getting that ARD data down, I think is the wrong approach. Instead, we should be looking at technology. In fact, one thing that we had proposed to NASA, a team that I had set up together for LandSat, was to get a 15 satellite LandCon constellation, which we named, with hyperspectral data. And as you know, the prevailing sentiment within the NASA scientist community is to have the raw data without anyone's fingers touching it. And so in order to do that, the technology has to be advanced to have high bandwidth communication, such as, say, laser optical comm, where you have communication from the LEO satellites that are acquiring the data, maybe to a geo relay that then sends it down. So you have much higher bandwidths that are talking about. So every time we hit this kind of chicken and egg situation, I'm sure there'll be smart people who will come up with a technological solution to getting rid of that roadblock. And so I agree with Dan that onboard computing is a high priority, and especially for businesses, that makes a lot of sense. But also, it'll be interesting to find out how to get the raw data directly down in such very large volumes.
Yeah, good points, both Tom and Dan. And I think this speaks to the ongoing synergy that will occur between government and academia and the commercial industry. Is there's different objectives, different resources. For instance, Orbital Sidekick may have one approach, and Tom, SaraniaSat may have another, and yet, NASA and ESA are going to have yet another. And with the government institutions do have an obligation to their taxpayers to be providing the data they are collecting. So those missions, by definition, will have that as part of their mission statement. But we can certainly see the private companies proceeding differently. And it's just how do we have that all best work together?
Can I add something, Jamie?
Absolutely.
I think that so part of the the AI revolution that we have seen started 10 years ago with the advent of new computing power, new GPUs, and the availability of free data sets for training those models, like ImageNet, Coco. Those are data sets that have been produced. They've produced thousands and thousands of papers, and thousands of people have worked with those data sets. I feel that if we want to do the same thing in the remote sensing community, we should be able to create data sets that are freely available for the users so that people can actually start using them and create new added values. Every time I read a new paper on hyperspectral processing, 90% of the time they either use Indian spine that is a 30 years old, 40 years old data set, or the Pavia data set. So we need to put data sets out there. And I don't know if you guys are familiar with SpaceNet. SpaceNet is a consortium of different companies, include Maxar, Planet, AWS, Capella. So we are all contributing to this data repository, and we are all contributing with images and labeled data. And I think that we need to do this also in the hyperspectral community. We need to have data set that address a specific problem with the proper labeling. Once we have this, then you will see a much greater adoption by users. If we don't give users data, they're not going to be able to develop anything in a short amount of time. Maybe in 30 years, 40 years, maybe. But
yeah, that's a really good point, Fabio. I think getting those types of sample data sets available so people can practice their trade, can learn, can also have training data to be applied is critical. And to one of Dan's points, I think one of the things that is crippling kind of some global adoption, I've seen some of this in the chat. It's like, well, where do I get data? I'm blocked from NASA sites. NOAA isn't, allowing a license. And I definitely dealt with that with Thesis being 2.5 nanometer spectral resolution. We were limited by NOAA to 10 nanometer depth delivery outside of the US government. And I don't know whether there's a grand deciding body out there that can help advise how we get tools and training data and what we were talking about with analysis related data. I mean, I don't think that's OGC's responsibility. I don't know whose responsibility that is, and maybe that's, if one of you know, certainly welcome that. But I think you bring up a really good point of bringing in data sets that people around the world can use to advance the science, especially with machine learning being what it is and being able to share training data across data sets. And again, that depends on having good data to start with. But yeah.
Yeah, I think we could all agree one of the major questions we get asked every day pretty much is, where do I get data?
Yeah.
And I think that falls on us as a community. Is there are lots of data sets out there. There's far more one-off data sets, but there are multi-temporal data sets. There are rather expansive hyperspectral data collections, and it's a matter of getting them more accessible and raising the awareness of them. And that of course takes time and effort, which is why some of them aren't available, is to standardize the imagery, to get it to whether it's analysis ready data or whether it's even just a standardized radiance correction to be used. That takes a lot of effort, and people aren't always funded to do that. But with all that said, as we start winding down towards the end of our session, let's go back to our initial question, which was the future of spectral. So in a nutshell, let each of you give your quick thoughts on that. So Tom, let's start with you.
Well, I think you're talking to a really biased audience in terms of the future of spectral, right? Yeah, I would necessarily have to say I'm bullish about the future of hyperspectral because the applications for it I see are only going to grow. And possibly that was the same explanation given 30 years ago, but now, as Fabio mentioned, we have some really sophisticated tools and to deal with these kinds of data sets and be able to derive actionable information from them far better than we were able to, I would say, 30 years ago. And so big data no longer scares us as much as it did in the past. So hopefully that'll be a good portent.
Great. Dan?
Yeah, I think as folks said here, the H cubed is really going to continue to be a big part of this here. And just global persistent monitoring with hyperspectral at high resolution, and the end goal really being real time or as close to near real time extraction of actionable information and delivery of that information to end users. That's the goal, and it has to remain the goal, I think, for hyperspectral to really maintain a strong foothold as we grow into the commercial sector. And commercial should, I strongly believe, needs to be the focus here, and less on the government side.
Fabio, your thoughts?
I think the future of spectral is not just spectral. I think we are gonna see like a nice data fusion mess in the upcoming years. Try to integrate multiple sources of information, and I think we should try to put the end user at the center of all these. Many users, they don't care about raw pixels. They might not even understand pixels in general. They just want information or insights. And so try to put the customer or the end user at the center of all the remote sensing is where we should try to aim. Again, spectral and hyperspectral is just one tool in our arsenal.
Agreed.
Great. And Amanda?
One of the reasons that we call this spectral sessions and not hyperspectral sessions is because, yes, there's a coming revolution, I think, with hyperspectral imagery, with small sats and some of the other available data sets like DSIS that are out there. But multispectral imagery, like things like what I've seen with WorldView 2 and 3 are phenomenal, and it can offer a lot of information at a very different spatial resolution. So what I see going forward in the future is a lot more fusion of across sensors and working with the time domain also being part of that spectral element of, you can take a hyperspectral image and you get an indice from that, and you have a narrow band index, and that can probably give you more accurate results than maybe a broadband index. Prasad kind of talked about that this morning. And then you take that single band, and that single band, you can combine 80 of those over time or more, and you're getting information that is both spectral and temporal, that can give an informed decision-making for the future in terms of doing predictive analyses. So, obviously I think it's got a bright future. I wouldn't have betted my career on it thus far if I didn't. But I think seeing everybody's presentation this morning, the wide variety of talks and the people who are on this panel here, it's a science, it's a craft, it's something that can be simplified, it's something that can be very complex. And again, if you can know where you're going, you can find the spectral data that's going to suit you best. And hopefully there's people who can help you along the way to get there. But I'm very excited. I have to plug in for DSIS for space-based system. It's an amazing system that is very good and clean. The 30 meter pixels can sometimes be a little bit frustrating, but for what's been produced from space in the last couple of years from it, I'm really happy with it. And I think it just pretends even better data coming in the future. So I'm really excited.
Great.
Yeah, I just wanna, I don't know if you have 2 seconds, but I don't think the spectral is going is not going away. There are specific applications like greenhouse monitoring or mineral exploration or marine debris, precision agriculture, things like that, where spectral is the main source of information, and so that's why I really like this time in history for remote sensing, because there is so much that we can do, and we get empowered now by all those constellation and sensors. So that's fantastic.
Yeah,
I like that, and that's a great spot to finish. These are exciting times, and it really is a spectacular time to be in remote sensing. Thank you all, and I believe it is back over to Joey to close us out.
Yes, thank you. And what a great panel to end on. As I watched today, it was really amazing to see the dialogue from people from all walks of the community, come together, ask questions of some of these amazing speakers and panelists we had today. And I think that's really what it takes to have this community continue to develop and, keep moving forward. In the absence of in-person conference, finding ways to continue these conversations and make these connections is really invaluable. For me, some of the really cool takeaways that I got today were it's never too young to start sharing that spectral technology, whether it's, showing someone, hey, you can use spectral to help identify some flash fuels and help prevent your house from burning down, or Did you know spectral data is used in CSI? We can help identify clothing and blood, or just talk about more of the core uses of why hyperspectral and spectral data was put together. And that's, conservation, protecting our environment, helping take care of our ecosystem. And I think one of the really cool takeaways in the last panel session here was, if we want to continue to see the spectral adoption in the community, we've got to make more of the data sets and the label data available and help people be training on, our most modern, most up-to-date data that's out there. And I think that'll really help us continue to innovate and pioneer. So really a great session today. And I want to thank our speakers and our attendees and all the team who helped put this together.